The last section of chapter 6 is 6.5, and it's called proportions in triangles. So what we're going to do in this section is talk about something called the side splitter theorem. And what that says is that if a line is parallel to one side of a triangle and intersects the other two sides, then it's going to divide those sides proportionally. Okay, so we'll see exactly what that means in this first example here. So we want to find our value of x. So what this says, and this is only because, again, that these two things are parallel here, I can say that this piece to this piece equals this piece over that piece. Okay, so in other words, I can do 12 over 14 equals 15 over x. And again, the order that you go in matters. So since I did 12 over 14 on the left, and 12 was part of that top little right triangle there, the top triangle, I had to do the 15 on the right, on the top, on the right hand side of that proportion. Okay, and now we're just going to cross multiply and solve. So 12 times x is 12x, and 15 times 14 should give me an answer of 210. And when we divide both sides by 12, x is going to give you an answer of 17.5. Okay, so again, this is only going to work if you have parallel lines there. Okay, otherwise, we always have to do a full side of the triangle to the full side of the triangle. Okay, so in part B, I have x for this little piece on the top here, and 36 for this piece, and then the whole side of the right hand, the whole right hand side of that big triangle is 55, and then the small piece over here is going to be 45. So I'm going to do on the left x over 36. So I have to do the same thing on that right hand side. So I have to do this little piece to the piece on the bottom. I need to find that little piece first. How? The whole thing is 55 and this piece is 45. If I subtract that, that's going to give me that top piece is going to be 10. So I'm going to have 10 over 45 on the right. And then we'll cross multiply and solve here. So 45 times x is going to be 45x. And 36 times 10 will give me an answer of 360. Divide both sides by 45, and x is going to equal 8. Okay, so again, we're told in part C that these two things are parallel, so let's see what this is going to look like here. I'm going to do full side to full side here, just to show you that it works if you use a full side as well. Okay, so I'm going to say that 3 over x, so I went the left-hand side of that triangle to the base of that triangle. So I'm going to do the left-hand side of the big triangle on the right to the base, over the base on the bottom. So the whole side is going to be 8, and the base of that other triangle is x plus 5. And now we'll cross multiply and solve. So I'll have 8x equals 3 times x plus 5. Distribute that 3 through those parentheses. 3 times x is 3x, and 3 times 5 is 15. Subtract 3x from both sides, and I'm going to have 5x equals 15. Divide both sides by 5, and x is going to equal 3. Okay, sorry, the formatting didn't, when I converted this to a PDF, it changed some formatting here. Okay, so in triangle ABC, D is a point on AB, and E is a point on AC, such that DE is going to be parallel to BC. Okay, so again, let's draw a picture of what's going on here. So we have triangle ABC. So let's draw any old triangle. And again, doesn't matter how you start labeling. So I'm going to call that triangle ABC. Now that I have that, now the next part's going to be what matters. So now D is a point on AB. Doesn't matter where you put that point, but somewhere on AB, we're going to put point D. And E is going to be a point on AC, such that when I connect the 2 points, it has to be parallel to BC. So if I want to start at that point D, and I want to draw a line that's parallel, just so my picture's a little bit better, I'm going to make that my parallel piece there, and that means that that's going to be E. Okay, they then tell me that ED is X, and DA is 6, and CB is 6 as well, and BD is X minus 1, and we want to find ED. Okay, and ED is going to be the one that's represented by X. So really this is asking me to find X here. So once I've found X, I'm done. So again, I'm going to do the same thing that I did in the last problem, and I'm going to go the full side of the small triangle to the base of the small triangle on one side. And then on the other side of my proportion, I'm going to do the same thing. I'm going to go full side of that triangle to the base of that triangle. So let's talk about the red one first. So that's going to be 6 over X. And then for the purple one, this entire side, if I have X minus 1 and I add 6 to it, -1 plus 6 will give me an answer of positive 5. So that entire side in terms of X is going to be X plus 5. And that's going to all go over the base of that triangle is 6. So again, we'll cross multiply and see what happens. So I'm going to have X times X plus 5, and 6 times 6 is going to be 36. I'll distribute that X through. So I'm going to have X squared plus 5X equals 36. So again, I have a quadratic here. I have a squared, okay, which means I'm going to eventually have to factor this. So again, if I'm going to factor it, it needs to be set equal to 0. So let's subtract 36 from both sides. And I'll have X squared minus 5, plus 5X, sorry, plus 5X minus 36 equals 0. So again, I have a trinomial. To factor that, again, I'm looking for two things that multiply to a -36 and at the same time add to a positive 5. Again, going back to algebra. So I'm going to have an X, and those two numbers should be a positive 9 and a -4. Positive 9 times a -4 is -36, and positive 9 plus -4 does give me that 5 back. So I know I'm on the right track there. Again, we'll set each factor equal to 0. So I'll have X plus 9 equals 0 and X minus 4 equals 0. Subtract 9 from both sides, and X is going to equal a -9. And over here, we'll add 4 to both sides, and X is going to equal a positive 4. Again, I can't have two answers. So again, how do I know which one is right? Again, if X represents the side of a triangle can't be negative. So X equals 4 is going to be your answer. You will lose points if you don't get rid of the extraneous answer there. So make sure you cross it out. Okay, again, formatting here from the conversion. So this should say DB equals 3. And we want to know, is DE parallel to BC? That's what that says, just so we are a little bit clearer there. Okay, so in triangle ABC, D is a point on AB, and E is a point on AC, and DE is drawn. If AB is 8, AC is 12, and EC is 4, and DB is 3. Now we want to be able to tell, is DE parallel to BC? So how are we going to do that? If those sides are going to end up being in proportion, then they're going to be parallel. If they're not in proportion, then it's not. So again, let's draw a picture of what's going on here. So again, I'm starting off with triangle ABC. Don't care what triangle ABC looks like. There it is. D is a point on AB. So there's D. E is a point on AC. There's E. Okay, and DE is drawn. And again, if AB is 8 and AC is 12, and EC is 4, and DB is 3. Again, we want to know if these are parallel. Hey, I'm just going to fill in some pieces here. For example, I want to find out what AD is, just because I can. It's very simple to find. 8 minus 3 will give me an answer of 5. And let's do the same thing on the other side. I'm going to find the length of AE. So if AC is 12 and the EC is 4, 12 minus 4 would leave me with 8 for that little piece over there. Okay, so now we can use that one that we were using in the beginning, and I'm going to say 8 over 4, and I want to know if that equals 5 over 3. Okay, so if that's true, then my two pieces are going to be parallel, and if it's not true, then they're not going to be parallel. So when I cross multiply here, 8 times 3 is 24, and 5 times 4 is 20. 24 does not equal 20, so no, those two lines are not parallel. Okay, we also have something called a triangle angle bisector theorem. And what that says is that if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So again, in this triangle that I have here, triangle ABC, you can see that AP is my angle bisector. And again, what that means is if I do AB over BP, that's going to have to equal AC over PC. Okay, so let's see what that looks like into a problem here. So we want to find the value of X. So again, I'm going to do for my first side, I'm going to do this X over 18. And again, the order matters on the other side. So I did this bottom piece first. So I'm going to do the bottom piece first over here. And then I'll have my 10 on the bottom. So we're going to have 12 over 10. And then we'll cross multiply and solve. So 10 times x will give me 10x, and 18 times 12 should give me an answer of 216. Divide both sides by 10, and x is going to equal 21.6. Hey, don't be afraid if you get decimals. If you get like insane decimals, like 21.649254, then I would say that something is wrong. But if you get like a nice, neat terminating decimal, don't be afraid of them. Okay? There absolutely can be decimal answers. Okay, so we also have proportional parts and parallel lines. So again, this is just kind of basically going back to the triangles with two things being parallel, but now we're basically not completing a triangle. Okay, if I kept extending these lines like way up and way up, eventually you could see it would form a triangle in there. So this is really, that's why this is still part of this section, because it's related here. So if three or more lines, parallel lines, intersect two transversals, then they cut off the transversals proportionally. Okay, so again, if AB is parallel to CD is parallel to EF, then what that means is that AC over CE is going to equal BD over DF. Okay, basically, again, it's the same thing as that side splitter theorem from the beginning, basically, is what that is. Okay, so for 5, we want to find our value of X. So I'm going to do 45 over 18 is going to equal 52 over X. 45 over 18 equals 52 over X. Cross multiply. 45 times X is 45X, and 18 times 52 should give me an answer of 936. Divide both sides by 45, and X is going to equal 20.8. Okay, and that's it for part A. We wanted to find X, we found X, we're done. Okay, and now we have part B here. So again, what's going to happen is we're going to have, again, it's the piece over the piece over the piece. So the first thing I need to do is find that piece that I just made with the purple squiggly there. Hey, because again, I know the full piece is 92 and the top piece is 28. So if I take 92 and subtract out 28, that's going to leave me with, helps if I subtract right, 64. So this piece right here is going to be 64. So I'm not going to use the 92 in my proportion. I'm going to use the 64. So 28 over 64 is going to equal 31.5 over X. Cross multiply. 28 times X is 28X, and 64 times 31.5 is going to give me an answer of 2016. The opposite of multiplying by 28 is to divide by 28. Okay, and always double check my math, but when you do 2016 divided by 28, you should get an answer of 72. Okay, and that is it for section 6.5.